Everyone, today I'm going to be going over the LeetCode problem, remove nth node from end of list. Let's first read the question. Given the head of a linked list, remove the nth node from the end of the list and return its head. If we look at example 1, we see that our linked list has 5 nodes, 1, 2, 3, 4, 5, with 1 being the head and 5 being the tail, and it's 2. And we want to remove the second to last node from this linked list, which means that we want to remove node 4, like 4. So how I'm going to do this problem is by using 2 pointers, a fast pointer and a slow pointer. We want to keep a distance of n between the 2 pointers. So I'm going to have use a loop from 0 to n minus 1. And in that loop, only the fast pointer moves. After that, both the fast and slow pointer will move. And when the fast pointer reaches the tail, the slow pointer will be at the node right before the one that we want to remove. So let's take an example. So here, right, this is our example 1. Again, the linked list 1, 2, 3, 4, 5, and n equals to 2. So at the very beginning, we see that both the slow and fast pointer are at the head, and then we see that the fast pointer moves for 2 iterations. So at this time, the slow pointer is at node 1, while the fast pointer is at node 3. And starting from here, both the slow and fast pointer will move. So the slow moves to node 2, fast pointer moves to node 4, slow pointer moves to node 3, fast pointer moves to node 5. At this point, you can see that the fast pointer is at the tail, right? And you can see here, the slow pointer is right before the node that we want to remove. So removing the node will be pretty simple. We have a temp variable to hold the node that we want to remove, like next one. So we have a variable to store the node after the one that we want to remove, and then just do like a slow down next or next equals to temp or something like that. However, there is an edge case, and that edge case is what happens if n equals to the length of the linked list. So let me go down and show you this example. So here we have the same linked list, 1, 2, 3, 4, 5, but now our n equals to 5. So again, right at the beginning, our slow and fast pointers, they both start at the head, but for 5 iterations, only the fast pointer moves. And by the time the fast pointer is done moving, it's going to be null. It's going to be outside of the linked list after the tail. In this case, what we're going to do is right after the loop, we're going to have a check. If not a fast pointer, that means like if fast pointer is none with null, then we just return head on next. So now let me code this up. So we're going to have a slow pointer and a fast pointer. And here, in this loop, only the fast pointer will move. This is to give like the distance of n between the 2 pointers. And right after this loop, we check if the fast pointer is out of bounds. So if not fast, then we return head on next. This part only happens when our n equals to the length of the linked list. Like I showed you here, our fast pointer will be out of bounds by the time this loop ends. And so if that happens, we just return head on next because the node that we want to remove is the first node, it's a head, right? So we just return head on next. And this part, so while fast on next, so assuming that our n is not equal to the length of the linked list, that means that both the slow and fast pointer still have some room to move. So we're gonna move both the slow and fast pointers until the fast pointer reaches the tail. At this point, the fast pointer will be at the tail, and the slow pointer will be at the node right before the one we want to remove. So like I mentioned, we're gonna have a variable that stores the node right after the one we want to remove, and then we just do slow down next equals to temp. So effectively, like for example, like here, right? Our slow pointer is here and our fast pointer is here. We just bypass this 4, like so let me go back to this whiteboard. Oops. So previously, yeah, so previously you can see our slow pointer is at 3 and our fast pointer is at 5, right? And the node we want to remove is 4. So instead of having 3.next equals to 4, we remove this link and we just do this. And finally, we return the head. So let me just double check I didn't mess anything up. It should look good. I'll do a test run to make sure that I didn't make any typos or anything. Looks good. I'll submit this. But you can see that this is a pretty efficient solution, and the time complexity is O of n. Thank you all for watching.